Okay, we're recording. Cool. Thank you guys for coming. I know it's a busy week because apparently there were midterms and stuff like that. So I appreciate all of you showing up. Today, we're going to be doing something a bit special. Instead of having one person yap all the time, we're going to do sort of like a open mic night. Anyone can come and talk about whatever they want. And we have three people signed up today, starting with Aiden. So when Aiden is ready to present, he can come up. In the meantime, I can stall as he finishes his pizza. Okay, cool. So, anyways, we got three different topics. Hopefully, each one's like 15 minutes. Hopefully, all of them are interesting. And yeah, if you ever have any questions, make sure to ask. If you're interested, message the person in charge. They would love to talk more about it because Aiden loves talking about brain love. And yeah, and if we have extra time in the end, anyone can come up and say whatever they want into the mic. So, yeah, cool. Hey, okay, great. So,
Thank you. I'm gonna try not to get my pizza hands on the mic. One hand is clean, the other hand is not. I only eat with one hand. Oh no.
I forgot that you didn't have a PowerPoint, so we
Yeah, it's a PowerPoint. Sorry guys, I turned to the dark side. I use PowerPoint.
okay, slideshow. Cool.
Hey guys, this is Dr. Brainlove, or How I Learned to Stop Worrying and Love the Language. In case you can't tell, this is from a riff of Dr. Strangelove, and it's not really called Brainlove. I promise you guys. This is actually a language that's near and dear to my heart, and I wrote. You guys have probably heard about it. I've written it, an interpreter for it. It is the brain that you cannot say. Uh, there's, I don't know how to say it without like what? Oh yeah, yeah. If only. But it's the language of the masochists. It's the best language in the world. Okay, overview. What is brain love, or more commonly called brain fuck? It's an I know. That's the only time I'm actually allowed to say that word. It's an esoteric programming language it's not really brain love. It does not love your brain. It really wants to destroy it. It was developed by a guy named Urban Miller, and this language is one of the most popular esoteric programming languages in computer science. What other languages does everyone know? Like there's Brainlove, there's Lolcat. Yes? Yeah. Malbol? Okay. Oh no. That's the worst. Apparently they still haven't figured out the hello world for it. They did? They got it? Nice. Oh yeah, with the Matrix algorithm. Yeah, that was wild. Okay. Now the thing is, Brainlove is one of the fastest, most powerful languages in the world, with a whopping 30,000 bytes and only eight commands available to you. It's wild. It is also extremely syntax safe, right? Anytime, anytime it registers a character that it's not allowed to have, it'll just drop it and keep on going. It's very nice. Now, the idea of Brainlove is it's an easy language to grasp. You just have access to some memory and a pointer. And the way that Brainlove works, in case you guys don't know, is you're given a giant block of memory and a singular pointer, and the pointer manipulates the memory depending on the commands. It's kind of cool, and you can print in and read in and print out. Now, the thing is, since it has such a minimal syntax and it's literally just one singular block of global memory, it's very easy to interpret for. You can build an interpreter for. And that's what the story here today is. It's an example of build your own interpreter, but without having to worry about all the syntactical sugar. So let's say we're interpreting lines. Interpreting a language can be broken down into two sections, as written by Wikipedia. There's analysis and synthesis, where analysis analyzes the code syntax for the semantics, and then the synthesis generates the code and the optimizations for interpreting, which is kind of cool. So, like for instance, the Python interpreter actually generates byte code during line by line processing, and it runs it on a virtual machine as well. With BrainLove, we build your own virtual machine using other languages. The idea of the BrainLove interpreter is that it just needs to analyze the code. It doesn't need to worry about the syntax because anything that's not correct about the syntax, it gets dropped. And also, it's a giant global block of memory. Yes. I did not compile. I mean, it's written in C, so of course it's faster than C++. That's it. Just trust me, bro. Yes. It's interpreted, not compiled. I couldn't figure out how to compile. What? I could write a compiler, and honestly, BrainLove would be pretty cool to write a compiler for. One of my friends, I just recently found out yesterday, they wrote a BrainLove interpreter in Common Lisp, which is kind of cool. Which is honestly now I need to step it up. I need to write BrainLove interpreter in only assembly, x86 assembly, guys. What? Oh, absolutely. I'm not that smart. Yes. That's also my idea as well. I'm thinking like, oh, brain love? Yeah, yeah, that would be able to interpret brain love. I mean, it is Turing complete. All right. So what I went through was a code design phase. I designed my code with a bunch of inputs and outputs and such. Do not pay attention to my shapes. My shapes look pretty because they fit together. That is not exactly how you would flowchart a program input and output. But I designed it to be very much it takes in the variables and the file IO and initializes the variables. So for instance, our 30,000 block byte of rapidly fast memory, blazingly fast, and also the pointer. And then from there, we check the syntax. We go through in a list or a vector or whatever you want, a forward list or anything really, a heap. You could even use a heap if you want. And it goes through and it checks for yeah, well, 8 commands. You have your print, you have your input, you have your output, which are dot and commas. You have your increment and decrement, move your pointers over left or right, and you also have your looping. Now the thing is, the looping, the way that I wrote it was it just starts. It starts a flag and it keeps track of all the commands that are within the loop. Once it hits that, it runs recursively, which is kind of cool until the pointer where it's at it returns to a 0, which is designed in the esoteric wiki, Esolang wiki. Now, memory and me. The beauty of BrainLove is its ability to have memory entirely on a single block of global memory. I say single block of global memory, it just basically means every single time you go into scope, you go into scope and you fall out of scope, it's all global, meaning that it's not going to fall out of scope. It's going to stay there. And it's just you're manipulating memory. So a simple memory diagram is right there. I wrote where we have a pointer that points to a block of memory, and that's what BrainLove entirely is. Don't be afraid to mess with your memory in C or C++ or in BrainLove itself, because whatever you allocate, remember to free, blah blah blah. It's not too bad of a project. It's entirely just how do you control your memory and how do you move your variables. Any questions so far? Okay. Um, it's a great way to learn pointer arithmetic as well because you have to visualize in your head or written down where the memory is supposed to be, how it's supposed to be printed, and all that sort of fun stuff. You can see here that I used a queue to keep track of my commands and within every single scope. It's kind of dope. And you can see how it works. So I did not censor this. It's an example of the hello world in BrainLove. So you can see that within the BrainLove file that I have a bunch of BrainLove syntax, and I ran it inside of the BrainLove interpreter, and it printed out hello world, and you can actually see the breakdown of it. The breakdown of that, which is taken from Wikipedia, or not Wikipedia, but Stack Overflow, sorry. Um, it initializes the controller, so the counter, so it sets it all the way up to 70, or to 10, sorry, at cell 0. So that's the counter within the loop itself. And it keeps on through the loop, and it decrements the counter at cell 0, and you can see it all working together. I wish I could have had time to make an animation, but I was studying. This was at like 2 a.m. in the morning that I did this. So forgive me for that. All is forgiven. And thank you. And you can see right there is my GitHub that holds the BrainLove interpreter. Yeah. Yes. Each of the 8 commands? Yes. So the first command is the plus. The plus basically means increment the numeric that the pointer is pointing to. So you're adding 1 to the number that the pointer is pointing to within the block of memory. The open bracket is start the loop. So you're setting up a loop start and you're building and everything that's within the loop start and loop end, it has to be ran recursively until the pointer reaches 0. The until where you reach 0 within the cell when you check. And then within there, you can see that the close angle bracket or close angle bracket, is it called close angle bracket? No, not the square back bracket, the alligator mouth. The less than sign, yeah. The less than sign basically means move the pointer to the right. The greater than sign says move the pointer to the left. Minus sign means reduce the where the pointer is pointing to by 1. So you're subtracting by 1 on the memory block. And that is it, really. Yeah. Any other questions? I promise you, this is a great project to start learning how to write interpreters for. Currently, I'm building a new interpreter called Little C. Uh, I want to write, I'm writing it. I'm so writing it. I'm writing Little C and C plus plus. Yeah.
Thank you for that, Aiden.
Thank you. Well, thank you for inviting me to do this.
Of course, I love your. Yeah, I know it's so well done.
The computer did it for me.
Mm. Oh, do you know there's a wrapper for it called I use Arch Linux, by the way, where it replaces yeah. So there's a wrapper for BrainLove called I use Arch Linux, by the way, where it replaces those 8 commands with I use Arch Linux, by the way, Gentoo, I think. And so yeah. And so you just write those over and over again. Okay. The second presentation lined up for today is firewalls by me. And this isn't going to be like a theoretical, what is firewall, super in depth. This is a very practical, like, if you're in blue team setting up a firewall, this is what you need to know. And the most important thing is do not get burned by your firewall. Firewalls are very useful for protecting you, but if you play with fire, you will get hurt. So, what is a firewall? A firewall is basically this wall. So for the computers, you can see here, right? We have a network and you're going to have packet traffic on that network. So how computers communicate through a network is they send little packets of information to each other. A firewall is basically a system, I guess, running on your device that looks through all the incoming packets, reads their data, and says, hey, is this okay to move on or should we block it? So, for example, here I have 2 scenarios. There's you trying to connect to your server, and there's a hacker trying to connect to your server. They can both send signals to that computer because you can just send signals to any device. But for you, when your signal passes through the firewall, it's going to be let through and it can actually do stuff on your device. However, for the hacker, we're going to have a firewall set up so that once the packet goes there, the firewall sees it and drops it. It removes it. So your device won't even see the incoming traffic. So that is the whole idea of a firewall, to prevent bad stuff from coming to us and allowing the good stuff to come in. That's the whole point. So how do we actually set this up? IP tables. There's a bunch of different firewalls out there. There is UFW is probably the one that people like to introduce you to. It's very user friendly, but it's also not standard. Today, I'm going to teach you guys about IP tables because IP tables is present on almost every single Linux distro. It's on Ubuntu, all of the Red Hats. It used to be on Debian, then they removed it and replaced it with something called NF tables. Then in the next version, they changed NF tables to be a wrapper for IP tables. So it's like sort of still on Debian, but not really. Other way around, IP tables is a wrapper for NF tables. Sorry. So like you can still do IP tables on the newest Debian version, but under the hood, it's actually running NF tables because they switched. So IP tables, how does it work? There's a bunch of different commands, as you can see here. The syntax is kind of confusing and not friendly, so I color coded it. First, let's break it down piece by piece. First of all, chains. So chains in a firewall is basically a set of so for a firewall, we're gonna have rules. Okay. And when the packet comes in, we go through the rules and we say, okay, does it match this rule? Does it match this rule? Does it match this rule? Going down our list. And in IP tables, for the first match, that's the one that we're gonna follow. So for example, if I say packets for SSH traffic, I'm gonna allow that. And I receive a packet for SSH, when it hits that, it's gonna say, okay, we're gonna allow this packet. So there's with these rules, we group together into chains. And there's two main chains, your input, traffic coming in, and your output, traffic coming out. Pretty simple. For adding rules to our chain, we're going to use tac A to append it to the end. So we're just adding another command to the bottom. Tac I allows us to add it wherever we want. So your rules are going to be listed one after another in your firewall. And so these rules are going to be numbered. So tac I, if you want yours to be at the very top, you can say tac I1, and it would add your new rule to the very top. But if you add a rule and you realize, oh, I actually don't want that, you can delete it by doing the same thing. Tac D, and so for example, I could say I added a input rule that I don't want anymore. So I would do tac D input and then whatever the number. For example, tac D input 3. But if you're lazy and you don't want to worry about numbers and stuff like that, you can just do tac F, and that flushes all of your firewall rules. They all go bye-bye. This is nice to do a fresh start, but on an actual blue team network, maybe there's certain rules you need to have, especially for services like Docker. So I had highlighted that in red, as in you probably don't want to touch that. And then finally, this is going to be confusing. There's going to be many rules, so we want to be able to see them. You're going to do tac L to list all your rules so you can see it. Yeah. Does that make sense so far? Is it like I'm rambling? Are you guys following? Okay, cool. So this is just very simple. How do we add or remove rules? We want to get into more detail, right? We want parameters to our rules. We want to include specific data from our packets. So what kind of data can we include? Well, IPs, right? These packets come from certain machines. It would be nice if we could filter by machine. So in IP tables, the packets come from a source and they go to a destination. So for your input, you want to do tac S because it's coming in from the source. And when you're sending it out, you want to do tac D because it's going out to your destination. So a command would look like IP tables. Let's say I wanted to add a rule to go to IP 8.8.8.8, right? I'm going to say IP tables, tac A input. And if I want to allow traffic from 8.8.8, so tac A input, tac S, and then my IP, right? I'm allowing traffic in from that source IP. So that's how IPs work. It's very nice to do firewall by IP because it's the most specific, right? You can be sure, hey, I'm only getting signal from my device because I made it so only my IP gets traffic into here. But it's also the easiest to mess up because what if you typo your IP? Or there's some weird network stuff where the IP you see isn't actually the IP that they're seeing. So you end up saying, okay, I'm going to block all traffic except from my IP. Turns out it's not your IP. What just happened? You blocked all traffic. You can't even touch your service anymore. And you've blocked yourself out by the firewall, which happens a lot, and I'll get to later. But let's keep going. We can block by machine, but we also want to be able to block by service or our port. So if we want to block by a port, we're going to do tag p TCP because most ports or services use TCP. If it used UDP, then you would say tag p UDP, but that almost never happens. So you can just say tag p TCP, that means I want to use a port. And when you want to specify the port, again, there's this idea of traffic coming in versus traffic coming out. It can come in from so like the traffic can come in, and usually when you send traffic, you send it from any port you want, but you want it to go to a specific port. For example, when I connect over SSH, which is port 22, I can come in from any port I want, but I have to connect to port 22. So my destination port is 22 for the incoming traffic. It's kind of confusing because for IPs, right, we had TAC-S and TAC-D. TAC-S was incoming, TAC-D was outgoing. But now for ports, I'm going to say TAC-D is incoming and TAC-S port is outgoing. Because for services, it's what we're going to, is what we specify. So that's ports. And so after that, you would specify your port number. So for example, TAC-D port 22. Is everyone following with that? Yes, question. Oh, no, thumbs up. Okay, cool. Cool. So that's that. And then the final thing is interfaces. Your device can connect to multiple different interfaces. This isn't really that important. The only reason I specified is because your loopback interface. What that is sometimes your device sends signals to itself. This is for internal services like sudo and things like that. And if you block it, it might make your computer run slow. So usually you want to allow your loopback address to accept any traffic so that you can send yourself packets. That's the idea behind that. And here we do TAC A for the incoming, I for input, and TAC O for the output, O for output. And finally, the thing that really, really matters is your action. Are you going to allow those packets? Are you going to accept it? Or are you going to drop them and ignore it? So this is what you put at the very end. You're going to do TAC J accept or TAC J drop. Why is it J? Because it stands for jump for some reason. You jump to the action. It would make more sense if it was any other letter, but they chose TAC J. And that's how it is. So this is IP tables. It is confusing and it is very wordy and annoying to deal with. Yes. So the thing is, you just run commands in terminal. You would say sudo IP tables and then type your rule, and it automatically applies it. That's pretty much how it works. So everything is command line for this. Yes, Phoenix? I'm not sure if it's an included binary, but I know that it's present in essentially every distro. Except like Alpine. It's not present on Alpine, okay? No, it wasn't. I don't think so. Yeah, you would have to use a package manager to get IP tables. So for example, if you're on Debian 10, I think, or is it 11? One of those very specific versions of Debian that does not have IP tables for some reason, then you would have to install IP tables on that and then do it. But yeah, for all of your standard Linux stuff, we use IP tables. Any other questions on IP tables? Okay. Was this simple or was this too complicated? Medium, good, okay, cool. Because if you guys can understand this, you are going to do amazing on firewalls. This is the hardest thing there is to firewalls. Once you have this down, you're golden. So let's practice a little. Let's do a few rules. Remember, the first rule that matches is the one that's applied. So let's say, okay, I know this. I want to start setting up my firewall on my machine so that I can be protected. And these are the commands I'm going to run. First, sudo IP tables tac a input drop. Sudo IP tables tac a output drop, because I want to drop by default, but I want to accept from SSH. So that's what it's going to look like. Yes, Aiden. Exactly. If you were accessing this machine through an SSH connection which is usually what it is in blue team or red team, remember that IP tables reads top down. So what you just did is you said, okay, machine, do not accept any incoming traffic. So what that means is you can no longer send signals to your machine because you just denied all traffic. The problem here is we dropped first instead of after. So what you always, always, always want to do is accept first. Test your accept rules and have the accept at the top. Then you can drop. Does that make sense? Yep. Ben?
Yeah, it looks like IP tables and well, now NF tables code is actually in like present in the mainline Linux kernel
Oh,
source
so it's going to be in any Linux,
modern.
any modern Linux. Yeah, yeah, yeah.
Some kind of table based on IP table that dates back like it was going to be present.
Okay. Thank you for that information. So yeah, that's why it's important to know IP tables and I guess also NF tables because it appears everywhere. If you know one tool, you don't need to do others. Most of the time, you would be learning something like UFW, and then when it doesn't show up, you're like, I don't know what to do. But here, you learn IP tables, you're good for everything. So what happens if we do this? We lock ourselves out. Oh no. And then we have screwed the entire team. You have been burned by the firewall. That's not good. That's not good. So what can we do to prevent this from happening? Well, there's a little cool trick I found out, which is when you run a process on a computer, for example, let's say I connect to my SSH server and I run a command, like a script that I wrote up, and it's running. And halfway through the script, I lose connection, maybe because firewall rules. What's going to happen? I can no longer access my machine because I put up firewall rules, but I started a process on there. And the process is going to keep running until it finishes. So even if I'm not connected, because I started a process before I got kicked out, that process is going to go to completion. So the idea here is, hey, what if for our firewalls, when we add firewalls, let's create a script that says, okay, let's add our firewall rules. But after 5 minutes, let's remove all those rules. Would we do that? Because let's say we messed up our rules and we kicked ourselves out. Oh no, we're done for. We can't get back in. But since you started this script, we know that after 5 minutes, it all gets flushed. We can come back to it again. And so I have my script that I use for Blue Team right here, where we can see that that is exactly what happens. Can you zoom in on GitHub? Would that work? Yeah, okay. So ignore this. This undo part is what I have here. So you see all this weird stuff. Ignore that. Ignore this. Basically, what these do is they find the drop rule that I added to block everyone out. And it says, okay, find that rule, and then we're going to delete it, right? And we want to delete it for input and output. So that's what my undo does. And so you see here, before, like when I do stuff, so you see I add my rules, and then I say, I'm going to undo this after 10 seconds. So in case I kick myself out, it gets undone. And let's see, let's look at this example here. This is an example of blocking by IP, or accepting by IP rather. You see IP tables, TAC A output. So this is outgoing traffic. Since it's outgoing, it goes to our destination IP. And we want to do it by port 22 and accept. So this is firewall rules in action. Might look a bit complicated, but work with it enough, you'll get the hang of it. So that's the main idea I wanted to convey is scripts are awesome because you can't kick yourself out with them if done right. And so yay, you guys have learned firewalls. But not quite. Because there's a lot of Linux distros out there, but some of them, they like to be special. Like BSD. I don't know if you ever heard about BSD, but it's Linux, but not. They have their own special things. And so IP tables isn't going to work on this because they don't even have IP tables. Instead, they have their packet filter PF. And you're like, oh, I have to learn a new thing. Oh my God. But it's actually really nice because these guys, instead of using random flags, they use English. If I want to block traffic, I say block. If I want to pass the traffic and let it go through, I say pass. If it's, huh? It is three extra characters. This is a lot more wordy, but it is intuitive. So let's say I wanted to allow incoming SSH traffic. I'm going to say pass in proto TCP to port 22. It's just going by those one after another. Okay. And it's the same thing as IP tables. I broke it up into the different things, right? We have IP, we have port, and it's the same format. It's just now it's words instead of blah, blah. And packet filter has some other cool features. For IP tables, everything had to be command line, which means we could only do like a script that runs it. But for packet filter, we don't use command line. We have a file with all of our rules. And you just say, hey, packet filter, use this file to be our rules. Use this rules file. So that's really nice because you don't have to run command after command. You just have one file with all your rules and you say, do that because I know that works. And it does it for you. That's so awesome. So how are we going to do that? You basically write a file with all of your rules, and then you're going to say PFCTL is the daemon that controls packet filter. So you're going to say, okay, TACF file, which means let's load this file and use it. And by default, it's going packet filter is going to be disabled. So if you want to enable it, you just say, hey, TACE enable. Or if you want to disable it, say, hey, TACD disable. It's much simpler than IP tables. You don't need to delete rules. You don't need to flush rules. You just enable, disable, switch rule file. And that's that. The other cool thing is for IP tables, let's say I wanted to allow SSH, but I also wanted web traffic. So that means I need a rule for port 22, for port 80, for port 443. And if I have other things, maybe I need port 53, maybe I need blah, 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 right? We have so many things. And we have to do this for input and output. And like, oh my God, now we have like 10 different rules to do one simple thing. That's annoying. So packet filter is like, let's not do that. Let's just make a list. And so you can list it in those curly braces. And it basically combines all of those rules into one. How neat. Yes, Aiden. You can, I don't think you can. In IP tables, you can? Okay, you can do a subnet. Yeah. Okay, so for IP tables, yes, you can do subnets. For packet filter, wait, you can do ranges with dash and IP tables? Okay, I did not know that. Okay, then ignore that bullet point. It applies to both. Instead of doing a single IP, we can do IP ranges and subnets and stuff like that. So that applies to both. But the thing I really, really like is tables. So let's say we wanted to block or allow by IP. And in IP tables, what we would do is we would have to make a rule for each IP, and that IP would be hard coded into our rule. For packet filter, we don't need to do that. We can just say, create a variable and say, hey, I'm going to make a table. This table is going to contain all of the IPs I want. And you see this command here is used to add entries to a table. So for example, if I wanted to make a table named IPs and I wanted to add 8.8.8.8 to it, then I'll do pfctl, tac-t, IPs, tac big T, add 8.8.8.8. If the table doesn't exist, it creates it for you. If it exists, it adds it to the table. So it's very nice and simple. And if we ever want to use that table in a rule, we just put the table name in those angular brackets. So it's a lot more easier to work with because we don't have to list IPs in our rules. We just say, hey, add it to the table, boom, we're done. And the weird thing about packet filter is unlike IP tables where the first rule is the one that we go by, it checks all the way to the end. And the last rule that applies is the one that we go by. So instead of reading top down, you're going to read bottom up. Except if you use quick in your command. If you just say quick, then it stops there once it reads it. And it's like, okay, we're done. But that's packet filter. Did that make sense to you guys? And slightly less. If you understand IP tables, it's the same concepts. except with extra features. You don't need to use those extra features, but they can make life easier. So let's go ahead and look at my rules file. So it's this bad that I said block first. Yes, Aiden? Exactly. Yeah, this is not IP tables. We read bottom up. So this is the last one that gets applied. Um, so yeah, basically we're saying here, by default, we want to block input and output traffic. However, I want to allow my loopback traffic for speed and efficiency purposes. And here, these rules, I have a table called imps, which includes all of the IPs I want, and I want them to be able to connect on port 22. So that's what that does. And if we look at my script for actually doing it, it's a lot smaller than my IP table script, that's for sure. I just disable my packet filter before I do anything. And then I say, hey, let's load the rules. I'm going to add my IPs to that table I created. And then I'm going to enable the rules. And I'll have my firewall up. So that's how that works. Any questions? Okay, cool. That is everything about firewalls. Thank you. And now we have Nathan. Oh, thanks.
Hi. Okay. Hi, I'm Nathan Fedriga, and I'm gonna hear talking about Kimu KVM, the best hypervisor. Well, best, I guess. If you don't know me, I have a lot of VMs on my system. I have in the screenshot here, I had about like 20 VMs, like some six running at once. I also had a macOS VM, and I use it all with Kimu KVM. Um, because it's faster. So let's talk about the existing virtualization solutions in Linux. You have the standard VirtualBox. It's in Windows, it's in macOS, it's in Linux. It's packaged into one nice, easy to use program. Uh, but it's boring, right? Um, you also have VMware, the commercial solution. It's if you in a big company, they probably use VMware. They have very high compatibility, and yeah. Uh, Kimu KVM a bit more complicated, a bit more Unixy, and it's also just on Linux, but that comes with some benefits and also some drawbacks. But we're gonna focus on the benefits because it's more fun. So why do I call it Kimu slash KVM? Why don't I just call it Kimu? It's because it's a stack. It's a virtualization stack on Linux. It's not just one package like VirtualBox. It's not like VMware. You can you can mix and match, but usually people go with Kimu KVM. So, what are the individual components? KVM, it's at the lowest, it's at the bottom most, it's closest to the hardware. It's a loadable kernel module, and it's the thing that actually enables virtualization. It actually takes advantage of the individual processor, like your individual processor instructions. Like for Intel, you take advantage of VTX, and for AMD, you take advantage of AMD-V, and it makes your virtualization much faster because it's in the kernel. It's not going through. It's not like VMware or VirtualBox. It doesn't go through your OS. It doesn't make a syscall, but it's straight in your kernel, and that's what makes it so great. It also has options for like para-virtualized Ethernet, disk I/O, and VGA graphics, and other solutions, other virtualization solutions have this too. But the main benefit from it is you're not emulating a whole. Of course, this is optional, but you're not emulating a whole like Ethernet driver. You're not emulating a whole disk. Your guest OS basically will know that, oh, I'm being virtualized, so just send it straight to the host. Kimu is actually the emulator. It's the GUI. It provides you with the actual screen, and you could send inputs, outputs to it with a keyboard and mouse. Um, It can also be used on its own to emulate other architectures like MIPS, PowerPC, and ARM. And but you usually want to use it with KVM because so your guest will be hardware assisted, uh, and you're able to virtualize it much faster. Now, to start a VM with QEMU, it's easy. It's not. You have to type in this whole big command to just get something to run. And to mention, you have to even type in another command, which I didn't include, but you have to instantiate another disk, and it's very command line heavy, right? So I don't want to write shell scripts just to start my VMs. So we're gonna add something else. We're gonna add something else to the stack. We're gonna add libvirt. And this is just a programming library, and it's a tool to manage your virtualization. It makes dealing with QEMU much easier, and it's basically necessary if you want to handle multiple VMs at once that want to interact with each other. It lets you create, monitor, and control virtual machines, and most importantly, it also makes networking between the VMs much easier. You could use it via the shell called virsh sh, and you can also script it with C, Python, and Go. That's not much better because I don't want to use a whole shell just to start my VMs either, and I definitely don't want to use C. So, yeah, I don't want to use C, unfortunately. Yeah. So, yeah, we're gonna add something else to the stack. It's getting a bit complicated at this point, but trust me, this is the last thing. Virt Manager. So, it's a GUI. It's just a GUI for managing libvirt, right? And it's hard to keep all this in your head, but we'll take it from the top to the bottom. Virt Manager is the GUI that lets you control libvirt, and it's very easy. You can create VMs with just this button, and you can start VMs with the start and the pause, and yeah, it's something you would see in VMware VirtualBox. libvirt is the middleman between Virt Manager and QEMU. It makes managing the VMs just like more unified, more easier. And QEMU is actually the bare, like, what actually starts the virtualization. And KVM is just to make things much faster. You don't really need to know that much about it. It's kind of, you could think of it as magic to make it faster. Of course, since this is a stack, you can also just replace things. Virt Manager can be replaced with GNOME boxes. So if you don't like how the GUI works, just use GNOME boxes. And there's also other things, but it's usually just Virt Manager that's mostly used. You could use QEMU on its own. Yeah, you can. And this will basically just emulate the whole hardware. It will emulate a whole CPU, it will emulate the RAM, it will emulate the disk network, and it is very, very slow. I know you mostly just use it to emulate other architectures, since you can't use KVM with other architectures. But, if you want to use x86 on ARM, or if you want to use PowerPC on x86, you could do that with QEMU. And actually, I just learned this recently. You can actually use VirtualBox with KVM. Yeah. Yeah, it's no, I don't use that. It does make VirtualBox fast. I'll be honest, it's a little janky from what I saw, but yeah, a lot of things can hook onto KVM. I read somewhere VMware is also trying to switch to KVM instead of its own thing. So a lot of virtualization is just coming through the kernel, and it's much faster. So, oh yeah, also Proxmox uses QEMU. So Proxmox tries to hide it from you, so you don't have to deal with all this stack things. But if you need to troubleshoot or debug, it's good to know how it works. So what was all this for? And I've said it 3 times, I think. Speed. You get very close to the native performance of the CPU. So I think this is a Cinebench or Geekbench benchmark. And yeah, as you can see, the blue one is the host, run on the host, and this is the KVM version. So if you need something very fast, if you need something very I guess lightweight and lowest latency, um, choose KVM. Uh, Same for disk too. And in fact, I was actually surprised from this because sometimes it's actually even faster. KVM performs even faster than host, which I actually don't know how that works. But I don't know. Yeah. um, Another thing that could be done is GPU pass through. Um, VirtualBox can also do this. VMware can also. Yeah, yeah, yeah. It's not worth. But don't throw your old GPU away. And it only takes a couple hours to set up, which is honestly not that bad. It could be worse. It could be worse. But it basically just gives your guest full access to your secondary GPU, like as if it owned it. Um, it can accelerate the graphics performance. You could video edit on it if you don't like video editing on Linux for some reason, you want to use Adobe. um, so yeah. But the biggest benefit is gaming. So, everyone wine is getting better, but let's be honest, there's still a couple bugs. Some games don't run. You want the native Windows version. Um, so if all your games run on if you use Windows for gaming and you don't like dual booting because whenever you update Windows or you update Linux, they try to kill each other and then now you can't boot on anything else. This is a good alternative. Just virtualize Windows. Yeah. Oh. Ooh, okay. So most user space, um, anti-cheat tries to detect it. Some don't care. Some care. You could hide it if if you want to, if you want to risk getting banned. Um, some kernel level anti-cheats like Valorant, League, Destiny 2, they don't allow it at all. But you know, almost all other games that aren't very hostile to virtualization, it works flawlessly. And when I mean flawlessly, when I had this set up, I could not tell the difference. I couldn't feel the latency. I had it on 240 hertz and I couldn't tell Windows was being virtualized. And this is great because, if you're on Linux, coding, doing something, and you want to start gaming, you don't have to move to dual boot. You don't have to restart your PC and then start Windows just to play a game. Um, yeah. Yeah. Steam VR is almost much better. I know Steam VR works on Wine. I don't know why people say that. It's very buggy. But pretty much almost all games work. Some other niceties, and this is the last slide, but Kimu also allows direct kernel boot. So if you like to, I guess, mess with the Linux kernel, you don't have to stick your kernel inside the VM and then have your grub or whatever bootloader try to load it. You could actually just directly load the kernel from Kimu as a command line option. Live migration. I haven't tested this, but I see the option everywhere. Um, if you have like a whole QEMU setup like across your network, you could actually move um your VM to another one, and it's good if like your host is about to go down and you need that service to still be up. I know Proxmox does it, and yeah. Per virtualized drivers, I said this before. You don't have to emulate a whole like Ethernet or a disk. You could just the guest will know it's being virtualized and just send that data over um, directly to your host, and that's done with VirtIO. I didn't write that down. There's also CPU pass through and pinning, kind of like GPU pass through. You pass in another CPU if you have another one, if you're rich like that. You also pin some of the cores so that your guest has direct access to your CPU cores, and you can also hide your VM if you want to run like malware and you don't want it to know it's being virtualized, or if you have, I guess, an academic software that doesn't like being virtualized, you could hide it. But yeah, that's pretty much it. Thank you. But you can't?
They're running a thread. So
Oh, okay. I guess you can't
no matter what you do, it's a thread. You can't have your kernel stop using that.
Oh, yeah.